this is Shweta. Welcome to my classes. Today we will be understanding the concept of covalent bond. So in chemical bonding now we have covalent bond, ionic bond, coordinate bond, so on. Okay. So in that ionic bond I already have discussed in one of my videos. So today we will be discussing the covalent bond. So you have already studied that in ionic bonding. So ionic bonding is between the metal and non-metal. So ionic bonding will always be between metal and non-metal. So this you have studied, isn't it? So ionic bond means the force of attraction between the metal and non-metal is considered to be ionic bond. Then what is covalent bond is? So covalent bond means here there will be no metal and non-metal, but there will be both the non-metal. So here the force of attraction is between non-metal and non-metal. So here the force of attraction will be non-metal and non-metal. This is the point to be remembered. So you have to consider two non-metals, then whatever the force of attraction or two non-metals together are binded by your covalent bond. So covalent bond, what you have to remember is that electrons are shared but they are not transferred. Okay, whereas in ionic bond what you had learned, so in ionic bond there was transfer of electrons, isn't it? So in ionic bond there was transfer of electrons, but in covalent bond there is no transfer but there is sharing of electrons. This you have to remember. So covalent bond is formed by sharing between the two non-metals. Okay, so whereas in ionic what happens, one metal and one non-metal will be there, there will be a transfer of electrons. Okay, you can see the video for ionic bonding. So here in covalent bonding what happens is there will be sharing of electron between two non-metals. Okay, so there is no transfer of electrons, but only the thing is there is sharing of electrons. So let us study with the examples. So first example let me take is a hydrogen molecule. Okay, so I take hydrogen. Okay, so here hydrogen is made of two H. Okay, one H I take, one H I take. So you know that it will be having one outermost valence electrons. So whatever I am showing this dot now, this is nothing but your valence electrons. You have to consider the valence electron. Valence electrons are those electrons which are in the outermost orbit. Okay, so you know that every atom, okay, every element wants to be in the stable state. So its stable state is octet. You have to remember octet. Means in outermost orbit there should be 8 electrons. But there is an exception for hydrogen and helium. So for hydrogen and helium, your stable octet structure is 2. That we will call as diplet. Okay. So this is the diplet rule. So for hydrogen and helium there is an exception. What exception? So it should fulfill the diplet rule. That is, its outer configuration should have 2 electrons. Then it will be stable. Whereas other elements in the periodic table, it will be of octet rule. It should satisfy the octet rule. Then only it will be stable. So here, now here it is having 1 electron and even it is having 1 electron. So both are unhappy because here even this hydrogen wants 1 electron to be stable and even this wants 1 electron to be stable. So the only thing possible is what this H says, give me some electron for some time, and even this says give me some electron for one time. So here what happens, there will be no sharing of electron. If this will be shared, there will be no transfer of electron. If this electron is transferred to this, then it has 0 electrons. Even the same case with this. So what happens is here no transfer of electrons takes place, but only what happens, sharing of electron takes place. So what it does, there will be a sharing of electron between these two. So this sharing is shown by one single line like this, and this bond itself is nothing but your covalent bond. So how this covalent bond is formed? Covalent bond is formed by sharing of electrons but not the transfer of electrons. So this one bond indicates what? 2 electrons. This bond itself indicates your 2 electrons shared between your hydrogen. So this, since in this bond formation only 2 electrons are involved, means 1 electron from each. So since it is 1 electron sharing, it is said to be single covalent bond. It is said to be single covalent bond. Why it is single covalent bond? Because 1 electron sharing is there. Okay. If 1 electron sharing is there between 2 atoms, means 1 electron from 1 atom, then it is said to be covalent bond. Okay. This is in case of hydrogen. Now let us consider another example, that is oxygen. So let me consider oxygen. Okay. So in oxygen what you have, oxygen atomic number is 8. So its configuration can be written as 8 and like valence electrons will be like 2 and 6. So 6 are the outermost valence electrons. So if I take 2 oxygen atoms, then how I can write? So see, this is oxygen, I'll take 1, 2, 3, 4, 5 and 6. I should show 6 valence electrons. Similarly, another oxygen I'll take with the 6 electrons. Okay. So now these 6 are the valence electrons, and you know that to have this stable state, for this it should fulfill the octet rule. Means it should have 8 electrons and it should have 8 electrons. Again here both are unhappy because still it is deficient of 2 electrons, even this is deficient of 2 electrons. Both are in need of 2 electrons. Okay. So here also what happens, there will be sharing of electrons. What this oxygen will do, this oxygen shares these 2 electrons, that is it will take these 2 electrons for some time. Similarly, this oxygen what it does, even it will take these 2 electrons for some times. So what happens, here 2, 4, 6 and 8 are involved. Here also 2, 4, 6 and 8. So now both the oxygen are having 8 electrons, that is stable there. So they are sharing how many electrons? 2 electrons. Okay, 2 electron sharing is taking place. So this can be shown like this. So oxygen. So since 2 electrons are shared, we have the 2 covalent bonds and remaining 4 will be as usual here. Okay. So here since it is called as double bond, I can call it as a double covalent bond. Why double covalent bond? Because how many electron sharing is there? 2 electron sharing is there from each atom, isn't it? So there is a 2 electron sharing. Hence it is called as a double covalent bond. Here I said you each sharing is shown by one single line. Okay. So since 2 electron pairs are being shared, it is called as double covalent bond. Okay. Next example, let us consider the nitrogen. Okay. So consider nitrogen. So again nitrogen, your atomic number you know it is, nitrogen atomic number is 7. So its state will be like 2 and 5. Outermost electrons are 5. So we have 5 electrons in the outermost orbit. So I can draw 2 nitrogens. Nitrogen 1, 2, 3, 4 and 5. Here also nitrogen I will show 1, 2, 3, 4 and 5. So you can see again this nitrogen is unhappy because even this octet is not filled, this octet is not filled. It requires 3 electrons and even it is deficient of 3 electrons. So what it does is this nitrogen takes 3 electrons from here. Similarly this nitrogen takes 3 electrons from here. So again there will be no transfer but there will be a sharing of electron. What happens? This 3 will be shared like this and even this will be shared like this. So what happened? See here 2, 3, 4, 5, 6, 7, 8. It is having 8 electrons. Similarly this nitrogen 2, 3, 4, 5, 6, 7, 8. Like this what happens? There will be a sharing of 3 electrons. So here this nitrogen will have triple bond. So here it is called as triple covalent bond. Why it is called as triple covalent bond? Because there will be a sharing of 3 electron from each atom. Okay. So 3 electrons are shared with the 3 atoms. So I think you are understanding what is covalent bond. So covalent bonding means, as I said, it is between 2 non-metals. So here I have taken hydrogen. Okay, hydrogen and hydrogen. So since only 1 electron sharing is there, it is called as single covalent bond. Here in oxygen case what happens? It is sharing 2 electrons. Okay, so it is called as a double covalent bond. And in case of nitrogen it is 3 electron sharing, hence it is called as a triple covalent bond. Okay. Now let me take the example of chlorine. Okay, so in chlorine molecule, even chlorine outermost valence electrons you should be knowing. So there are 7 electrons. So there are 7 valence electrons. Okay, 7 valence electrons. So how I can write chlorine? I take 2 chlorine atoms. Okay, I should show 7. 1, 2, 3, 4, 5, 6 and 7. And another chlorine atom 1, 2, 3, 4, 5, 6 and 7. So I have taken 2 chlorine atoms and here I have shown the valence electrons. There are 7 outermost valence electrons. Now what this chlorine wants only 1 electron and even this chlorine wants 1 electron because to complete the octet. Okay. So what again, see, it can take 1 electron from here. Yes. And even this can take 1 electron from here. Again there is a mutual sharing of electrons. Okay. So here only these 2 electrons are shared. These 6 electrons are not participating in bonding, remember. Okay. Only these 2 electrons are mutually shared between the 2 atoms. Okay. So what happens? There is a bond formation between chlorine and chlorine. This is nothing but, and these, as I said, these will be remaining same as it is. Okay. So these are not involved in bonding. Only your sharing takes place between these two chlorine atoms. This is also an example for a covalent bond. Clear? So let us discuss another example. So now next example we will discuss, that is H2 I have taken. So here 2 hydrogen I have to show and 1 oxygen. Okay, and you know that hydrogen will be having 1 valence electron, and even this hydrogen has 1 valence electron. These both are deficient of 1 electron because it should fulfill diplet rule. Okay, and this oxygen wants still 2 electrons because it wants to fulfill your octet rule. So what happens is, here since this hydrogen is wanting 1 electron, what happens? This will take 1 electron from here. Okay, it will be stable. Similarly, this hydrogen will take 1 electron from here. This will be stable, isn't it? So both the hydrogens are stable by sharing 1 electron with the oxygen atom. Okay, now what oxygen should do? Oxygen should have again 2 electrons. So what happens? This oxygen will take what? These 2 electrons. Okay, this oxygen will take these 2 electrons from the hydrogen, each hydrogen atom, and it forms the octet. So how your oxygen will be shown is, finally, here 1 hydrogen will be there, and again this hydrogen will be attached, isn't it? So sharing 1 oxygen will share with the hydrogen and another electron will be shared with the hydrogen. Clear? So this is all about, so you can show the oxygen structure like this. So it will be sharing 2 of its electrons with the hydrogen atom. This is all about the covalent bonding. So it is between the 2 non-metals, remember, and summarizing point is what? Covalent bond is the bond formed between 2 non-metals and without the transfer of electrons. It will be only the sharing of electrons. Why the sharing takes place? Because it wants to fulfill the octet structure or diplet structure only in case of hydrogen or helium. So every element wants to be in stable state. If it wants to be stable, then it should be fulfilling its valence electrons, that is outermost configuration, that is octet rule should be stable. It should be fulfilled. So this is all about the covalent bonding. I hope you understood the introduction to covalent bonding. Thank you.